Okay, let's continue our discussion of risk, and we're going to talk about something called standalone risk. And then I'm going to introduce something, and don't run for the hills because you will be able to do this by the end of the lecture, and that is calculate standard deviation. So that'll be a very impressive tool to add to your overall financial toolkit. But let's talk about standalone risk. It's defined. It's a measurement of an investment that will be held in isolation. So, what do we mean by this? And the textbook also refers to this isolation concept. It really means it's not mixed in with a bunch of other investments. You're looking at purely this investment by itself. And again, that could be an MRI clinic, that could be any major project. But let's say if you were, what would be a portfolio of projects? Well, you could be looking at, well, we're going to do an MRI clinic, plus we're going to do an upgrade to the emergency room by adding new scanners in there, and then we're going to be building, I don't know, three more outpatient facilities as a whole, as a package, as a portfolio type of endeavor, meaning multiple items. This is not that. We're just looking at standalone risk. And standalone risk can be measured by the degree of tightness of the return of the distribution. And what that means, let's go back and look real quickly here at the at our expected returns from our distribution table that we have here. So really looking at the tightness of these returns based off of the expected return that we had. So let's say in this case, when we calculated the clinic, we expected a 15% return. How tight are these returns centered around that? They could actually be pretty, I mean, it could all be pretty varying. I mean, you could have 75% and as your top end maximum return, or a negative 100. That would be a lot of degree of variation that could happen to the project. So that would be very loose in its returns compared to something that's very tight. Or imagine if this was a negative, let's go pick on the MRI clinic, a negative 2%, and then a 0, and then a negative 2, or a positive 2, a positive 3, positive 5. That would be very tight, very tight. Not a lot of degree of separation around an expected return rate. So you got to think about that as well. And that is where we talk about the standalone risk, um, and how it's measuring that tightness of that return. And the term that we use, again, don't run for the hills, is standard deviation. And we often use the term sigma. So that little squiggly O right down there is sigma. Now, it's not too hard to calculate it, and we're going to work through a calculation for standard deviation so we can see how tight those returns are around an expected value. Let's stick with our MRI clinic, and we're eventually going to get to this point right up here where sigma equals the square root of the variance. Now, what you're going to need to do, as far as calculator wise, most of your standard calculators will have the things that we're going to do. We're going to do two things here. We're going to do a square root, and we're going to we're going to cube it, or we're going to be to the power of 2, which is on almost every calculator. If you have your standard phone calculator, I know that for iOS, you have a very basic calculator when you hold it in portrait view. And then if you just turn the calculator to its side, it will open up additional features. So you may need that in order to at least get the square root, um, and to do the power of 2, or to cube this product that we're going to get here. So what we're going to do, and what I'm going to do is I'm actually going to do this longhand for you. But again, I like you to get started. So I'm going to show you this first one, then I'm going to break the video. I'm going to come back. I'm going to hand write it for you, and then compare your answers. But simply what you're going to do is you're going to take the probability that was assigned to a particular event, and you're going to take your this one. This is the return of event one, or whatever you want to call it, the first probability, a -10, minus your expected return. Okay, so you work this in the parentheses first, and then you square root you to the power of 2. So, and then we'll do the square root at the very end. But first we got to calculate. We're trying to find something called variance first in order to get standard deviations. Just hold tight. Again, a little bit of multiplication here and some adding, and you should be just fine. So let's just double check. Where are we getting these numbers from? This 0.10, this -10%, -10. Remember, we're getting that from up here. Okay, there's our probability of a very poor economy, 0.10 or 10%, but we're going to leave it in the point form. And the bad economy would return a -10. We did calculate that the expected rate of return for this project was 10%. Remember, when we did all our calculations for the MRI project. So just going back to that, remember that was 10% for that guy right there. So let's go back and whoops, don't freak out. Sorry, don't freak out about that one. We'll talk about that in a second. That's where we're getting the numbers from. Again, this is your expected rate of return. Just in this case, it happens to be a 10. So don't let that throw you. It's 10, just like the return that the -10% return for the poor economy. So you do that. And try not to think about it too much. You just simply take, and I'm going to get my calculator out here. Again, I'll do this longhand for you, but I'll work on this first chunk, and then you're going to do each one of those different probabilities that showed up in that distribution table, and then you'll add them all up together. So in this case, let's just say we got our -10. -10 minus 10 equals -20. Probably do that in your head. And then you're just going to go ahead and get the square of that. Again, that's usually on your calculator. It's might be a little X with a exponent, a little 2 on there. You just click that button and you should get 400. But wait, you're not done. So you got the 400 and you're going to multiply it times that probability. So in this case, that was another 0.10 or 10%, but we'll leave in that decimal point. And you should get 40. Okay, so go back and do this same step, this little, 3-step process. You're going to do those for all of these right here. Okay, so we just did this one. Okay, so you're going to do this one, this one, this one, and this one, and then add them all up, and that's part of, I guess, that'll get your initial variance. So stop there, and then we're gonna go ahead and we're gonna get the square root of that. All right, so hold on tight and continue and work it yourself, and then I'll be back and we'll do it longhand in just a second. So pause the video and work through it is what I'm trying to say.
All right, well, let's take a look at this and how I like to set this up. And it makes it a little bit easier than the way that shows in the textbook or on the slides, which they have to do a little bit as far as kind of the way the formula is presented. But this might help make a little bit more sense. All right, so remember, we're doing the MRI center. First thing you want to do is list those probabilities of those events. And let's pick a color here. We're going to use green. Okay, so 10% chance of very poor economy, 20% poor, 40% average, good, and let's see, what do my notes say? Oh, very good was 10%. Then we're going to be multiplying that times something. Times we're going to do a little something in parentheses here. And if you go back to that chart, and hopefully you have that in front of you as you were calculating this, is kind of roll back the video and you're looking at our probability distributions. Do you remember what the return was? If the economy was very poor, again, there was a 10% chance of the economy being very poor, the return on that was a -10%. If it was poor, return of 0. If it was average, we were going to have a return of 20%, and then so on. And if the economy was absolutely outstanding, we're going to have a 30% return. Okay? Now, but do you also remember that we went ahead and calculated the expected return, okay? And the expected return for that MRI project, investment, whatever we want to call it, was 10%. We want to subtract the expected return off of there. That was 10. So we just go down minus 10, minus 10, minus 10, minus 10. Let's close our parentheses out. And we are going to square this. Okay, this is exactly as, again, listed, same as in the textbook, same as on our PowerPoint slides as well, as those will be squared. Now we just want to do the math that's in here. So we're just going to move along, boom, boom, equal, equals, and run through all of this. So 0.10 times, well, let's see, 10 minus 10, that's a negative 20, as I kind of said before, square. 0.20 times 0 minus 10, well, what is that? Well, negative 10 square. Whoops, that's a parentheses there. And we've got a 0.4 times, well, let's see, 10 minus 10, what's that? Well, that's a 0. Okay. And now we've got a 0.2 times 20 minus 10, 10, right? So far, math, pretty easy, right, guys? So this is not too bad. Just a little bit of multiplication going on here, and a little bit of calculator work. Not too bad. 30 minus 10, 20. And we're going to be squaring that or cubing it or to the power of 2, however you want to term that. So let's do, I'm going to pull out my calculator because I can't do those in my head. And let's get those calculated here. And let's see here, clear it out. Okay, 20. Negative 20 squared is 400. Okay, and hopefully, again, you're looking for that on your calculator. It's going to look like this. Okay, that little button right here. Boom, try that. That's the magic button. Okay? And let's do our 10 squared. Again, you could probably do that in your head, but I don't trust my head. Let's go back to my green here, sorry. That's going to be 100. And we got 0.4 times, well, that's 0, right? Actually, I can stop right here at that one because that's going to equal 0. Once you get a 0 in there and you're multiplying, it's 0. You would find that out if you multiplied it out, if you forgot that part from earlier math days, but that's going to be 0, so we're just going to end that one right there. And we've got another 10 squared, which we already know that is 100, but just double check yourself. Okay. And now we've got 20 squared. Okay, 400. And now we're just going to do that math all the way out and see what we get. So we're doing 0.10 times 400, 40. 0.2 times 100 equals 20. We already know that's 0. 0.2 times 100, we calculated that already, equals 20. Whoops. 20. And wow, that works out good. We've already calculated 0.10 times 400 equals 40. Add all of these up, and let's see what we get. And this, let's see here, will be your variance. Now remember, what we really want to do is our holy grail here is standard deviation, but 848, 120, right? All right, just doing the calculator to make sure, but 120 equals our variance. Okay, so we're almost there, guys. Now let's go back to the PowerPoint and finish this up.
All right, so we've got our variance, which is that 120. All you need to do now is you're just going to hit the square root button, and that'll give you your standard deviation or your sigma on the MRI facility, which is going to come out to be about 10.9, or we'll just round that to 11%. All right, so congratulations. You've calculated your first variance by yourself and with a definite walkthrough on that. Now what I want you to do is I want you to go to the clinic, back to the clinic right here. Here are all the numbers. Go back to the clinic and I want you to calculate it all the way through. I want you to set up the table like you did, run make sure you do the squaring and then the multiplying and then add them all together, get your variance, and then hit the square root button after you've added them all together, and let's see what you could find for standard deviation. I want you to calculate your first standard deviation by yourself on the MRI clinic, and then if you didn't get it right, I am going to do a by hand walkthrough on that one as well. Well, hopefully you've paused that video and you did work through the calculations for looking for the standard deviation and the variance for the clinic. And let's do the reveal here. The reveal is 18%. Standard deviation is 18%. You didn't get that? Well, all right, let's take a look on the next slide on how we did that.
Okay, let's attempt to, let me show you this longhand here, a little bit different format, bringing up a kind of a blackboard for you. So the first thing I would look at is how to set this up. And if you remember, we're doing the clinic. So what I would do is I would set up the various probabilities, which were 10%. We had the 20%. Remember, I'm writing this as decimal formats. 40, 20, remember the economy, the various outcomes for the economy, and 10%. But the very poor, right up here, going all the way through to very good. Okay? Then we need to know what those anticipated outcomes were for each one of those. Again, that was given to us in the problem for the clinic. And we have, let's see, negative 20%. Again, we'll leave it as a 20. We can do that. And then for the poor economy, there was going to be a return of 0%. For the average economy, we are looking at 15%. And as the economy gets better, then we got a 30% return, and then economy's going great, we got a 50% return. And if you remember, we calculated the expected return to equal, from this whole project, the expected return was to equal 15%. And if you look at the formula going back to the other slide, you want to take this probability in this column right here, and you want to subtract from it that expected rate of return, which was 15%. So far, pretty easy, right? Not too bad. Okay. Now you're probably saying, Chris, this doesn't look exactly like the way the book has it set up, or you have it set up in the slides. But in a minute, you'll see how it all it all sets up exactly the same. And we're going to want to put a parentheses around this, because what we have to do is we are going to the exponent of 2, we're going to cube this, or to the power of 2, however you want to think about it, but those are going to be a little exponent there. Okay, so don't let that throw you. But the first thing that you'll want to do the math that's right in here. Again, this is just subtraction, so not too terribly difficult. You do that subtraction, and well, let's just carry this all the way out here. Okay. All these are going to equal something here in just a moment. Let me just set this up a little bit more. Remember, too, that we're going to also, going back to the formula which is given to you, you're going to multiply those, the probability of the event happening right up there, times whatever this is going to be. Okay? Once you do one, you know how to do all the other ones. It's pretty simple. It's kind of a mechanical thing. So, negative 20, we'll bring it on over. We'll use a new color for this next column. All right, so we still have our 0.10 times, and in this case, we've got a negative 35, okay, squared. Go to your handy-dandy calculator, and let me pull up my calculator here as I'm talking to you. And just take negative 35 and hit the square button. Probably an X with a little 2 above it, and you're going to get 1,225. It takes away the negative, because a negative times a negative is a positive. So don't even worry about. I mean, as long as you plug in the negative, you'll be fine. It gets rid of the negative. So now this is going to equal 0.10 times, I'm going to run out of space here, 1,225. All right. Run that multiplication there, and you can see that's going to equal, again, because I'm running out of space, but 122.5. There you go. Great. You got that one. Now you're going to do the next one. Again, that'll be 0.2 times, after you do the math in here, that'll be a 0 minus 15 is a negative 15. You're going to square that. That's going to give you 225. Multiply those two together, and you're going to get 45. Nice. This next one, 15 minus 15 is 0. That's magic. When that happens, I know I'm done, because 0 squared is 0 and multiplied is 0. It's all 0. So we can just put in a 0 right there. Don't have to do any math here. Doing our next one, 0.2 times, well, let's see, 30 minus 15 is 15, remember, squared. I'm going to do 15 squared is, we're going to carry this, keep the 5 over there, or keep the multiplication going, is 225. Hey, great. Multiply those. And we are going to get another 45. Just happened to work out that way. Isn't that great? All right, and then our last one, 0.10 times whatever this is. Let's see, that's going to be 35. 50 minus 15 is 35, right? Yep. It's still squared. Do your little calculation. You'll find out that 35 squared, that's an equals, sorry guys, equals 10 times 1, 2, 2, 5. Just happen to be working out with the same numbers we did earlier. And then you're going to multiply those together, and that's going to equal 122.5. All right, so now what do you want to do now? You want to take these, add them up. And you can skip the 0, but we add them all up. And if you add all those together, let's see what we get. Hopefully you're doing this along with me. So 122.5 plus 45 plus 0 plus 45 plus 122.5 equals 335. 335. Now, what have you just found right there? What you found is basically the variance. You found the variance. And you can go back and look at the other slides. But this is the variance. But remember, we're looking for sigma, which is standard deviation, and that is the square root of the variance. So, what do you got to do? Just square root this guy. Again, your handy-dandy calculator should do it all for you. Just hit the square root button, blam, and we get 18.3 and a bunch of change. So 18%, that is going to be your sigma or standard deviation. Congratulations, you have just calculated your first standard deviation. So that's something to be proud of. Just know that you have to go through all these steps, and with it should be kind of a plug and chug once you go through it. But hopefully you see it as not being too difficult.
Now let's take a look at standard deviation graphically. That's kind of that classic curve that you see here, and really what it means by having kind of those tighter and looser terms, especially when we're using standard deviation or sigma. Now we calculated the clinic to have a standard deviation of 18 and the MRI was 11. So the MRI is a tighter, you have those expected returns are centered closer to the, I should say those returns are centered more around that expected return of 10, where we had an expected return of 15% for the clinic, but the returns on there were more, they deviated more from that standard, that expected return of 15. They were looser in this case. So there's kind of a graphic representation. Again, which one would you do? I don't know, kind of up to you and your own personal risk tolerance or the risk tolerance of your organization. For me, let's go back and look at that chart again. Seeing those returns, to me, the 20% differential in loss uh, seems to be okay. I mean, if I hit that, an extra 10% isn't going to kill the company, but I could definitely have a lot of up potential with the clinic with the extra 5 here, against extra 5% return, extra 10, an extra 20 there. So I think it looks, I would probably go clinic. I'd probably maybe risk my job a little bit, but um, versus going with the MRI machine. Again, the MRI is going to have the tighter returns, considered a little bit less risky, if you will, because those returns will be tighter around the expected returns. So, all right, so there's a little bit about those bell curves, you've learned how to do standard deviation. So get up and scream and tell somebody, hey, I just calculated standard deviation, and they'll think you're like some kind of math genius. But really, it wasn't that hard, was it?